Good morning. Just wanted to go over a few final points for Unit 662, and we're going to talk about the common form of faults on cables. Now, unfortunately, I don't have any proper distribution cable that you're likely to use in your industry, but for the purposes of this demonstration, I'll just use this 10mm twin and earth. At one end of the cable, I've connected a continuity tester, which is effectively a 9-volt battery, connecting, so you've got 9 volts appearing between the brown and blue phases here, just to demonstrate what happens. Now, at the moment, the brown and the blue conductors are separated by insulation, and insulation has a very high resistance. The conductors are very low resistance, and the most common causes of cable faults that you're likely to come across is where there's a breakdown of insulation between either of the two phases, or between earth and a phase. And we can demonstrate that by just using a pair of cutters. If I have these cutters, and if I squeeze without cutting the wire, just squeeze it together, you can imagine this could be a pickaxe or a JCB shovel or something like that, damaging the cable. And as I squeeze it, what's happening is the blade of the cutters is digging into the insulation and touching the conductor inside the brown and shorting it out with the earth conductor there. Okay. Similarly, you might get a dead short between two phases, and if I squeeze those gently, as I'm squeezing harder and harder, should get something. Here we go. And you can see the insulation just looks a bit dented there, but because I squeeze hard, it digs into the conductor and creates a low resistance path, which produces a fault. So for the purposes of this course, you need to remember that low resistance between phase and earth is a fault. It's low resistance. Okay. Righty-ho. The other thing I forgot to mention the other day was ring circuits. If you have an ordinary circuit like this, for example, if I have a supply there which is supplying some light bulbs like that, so I'll put 3 in the series in parallel here so that we can get an idea of what we're doing. If I connect that to, say, 230 volts, these 3 light bulbs will light up, and they'll all light up. And if I cut the cable here, all 3 light bulbs will go out. If I was to cut the cable at that point, these 2 light bulbs would go out, or if I was to cut the cable at this point, this light bulb would go out and these would stay on. A more reliable way of connecting the system to keep it lit would be to produce a ring, so to connect that end to there and this end to there. So that was, say, live and neutral. I've now created a more reliable system, because if I cut the cable at this point here, These two still stay lit because they're being fed from this end, and this one still stays lit because it's being fed from that end. If it was to cut the cable at this point, these three are still being fed from this end, and so on. So you get the picture there. Well, in your network, you might have a substation here, and this is feeding houses around your network. See, these are houses here, here and here, back into the substation there. And as you can see here, this is a house number 1, number 2, number 3, number 4. If there was a break in the cable here, then you could isolate the cable at one end using a switch, and once you'd separated the cables, you could bring back half of the network back on, so it would make it more reliable. So the main reason for using a ring is it improves reliability. That's what you need to remember in a distribution network if you have a ring system. Okay, so that's really why you improve that. Now, the ring systems can be applied to your customers' circuits, or they can be applied to your substation circuits. So instead of these being houses, these could actually be substations in a ring, and each substation would go off and supply houses, etc. All right, so that's the main reason for having a ring circuit. That's something you need to remember